Okay, welcome to Unit 3, Lesson 2, Newton's First Law, Example 2, Part 3. That 2, Part 3 is the last example on lesson number 2. We've made it through it, but not quite yet. This last example is a little bit longer, a little bit more complicated. Not exceptionally more complicated than the others, but it is definitely sort of what we've been striving to get to in this lesson. Okay, so we have an object and we have two forces pulling on it. These two forces are pulling on it at an angle. And the question wants us to figure out what the equilibriant force would have to be on this object to bring it to static equilibrium. Meaning, what force could we add to essentially cancel out the other forces so the net force on this object is 0 and it won't accelerate in any direction. Yikes, that sounded like a mouthful. So let us begin. Start looking at these forces here. Force 1 is up to the left. They've actually done us kind of a little favor. They could have given us the magnitude of each of these forces, force 1 and force 2, and told us what angle they were at. In the past couple units, especially topic 1, they did that a lot, right? We're trying to find the net force on them, and what they do is they would just give us forces at angles, and we'd have to use trigonometry to figure out the force 1x, the force 1y, force 2x, force 2y, and then we would figure out the net force from there. So they're actually doing us a little bit of a favor and saving us a little bit of math here. It's nice of them to do. Okay, well, we're going to use basically those same steps that we used in lesson 1, which was first we want to find the net x, second we want to find the net y, third we want to draw our net triangle so we can find force net. So let's go about doing that. What color don't we have used in here? Magenta. And we can say that, well, let's do force x first. So maybe I want to put on my little number line and say that the left is going to be negative and the right is going to be positive. And force Fx net. That's what I'm trying to say here. Force x net, or force net x. Now I've been doing this too long and I don't remember how I say words anymore, but Fx net is going to equal the sum of all the x forces, right? We can say this is force 1x, this one here is force 2x. So let's plug them together. Let's say force 1x is a negative value because it's moving to the left, so we're going to say negative 40 newtons plus 70 newtons. So Fx net is equal to 30 newtons. Wow, my math. 30 newtons. And that's going to be to the right. Let's keep that direction on there. I mean, just that it's positive is implying that it's to the right, but let's be explicit. Alright. Let's maybe use orange for our y. So we're going to be finding Fy net. And again, this is just topic 1 coming back to haunt us here. Fy net is equal to the sum of the y forces. This is F1y, this is F2y. They're both up. Up, I guess we don't have directions on here. We'll make positive, down we'll make our negative. Standard convention. Okay. So we can say this is going to be 50 newtons up, so positive, plus another 30 newtons. So far so good. Our Fy net value is equal to 80 newtons. Okay, now we basically have what we had in the example 2 question. We've got 30 newtons to the right, 80 newtons up. So let's draw a new triangle. I'll draw this triangle, I don't know, in blue maybe. Okie dokie. Remember, this triangle is still tip to tail. And how did I drew it? I drew it across and up in my diagram. So I'll keep it that way so I can use my own answers. So we've got 30 newtons right. And then tip to tail style, we've got 80 newtons up. I'll try to make it a little bit longer at least. And our resultant force, our net force I should say, is up and to the right. So this is going to be, whoops, F net. This is our 80 newtons. Right, that's our Fy net. This is our 30 newtons right. Our X net. Cool. So, with these two forces pulling on it, essentially the up forces add, so there's quite a strong upward force, and the side-to-side forces are battling each other. So they kind of cancel each other out, but the right one is stronger, so it wins out. Meaning this thing is going to move up and to the right. Okay, well, we're still looking for that equilibriant force, and I haven't solved any of these angles or anything yet, but I think what we're going to do first is we are going to solve F net. Okay, F net is going to equal, we're going to do some Pythagoras, so it's going to equal the square root of 30 squared plus 80 squared. So our F net value works out to 85 newtons. There it is. 85 newtons. Okay. So, something I did in the last lesson right at the end that I briefly demonstrated and explained, I'm going to do it in this question. Okay. And for finding the equilibriant, if our force net is up with this angle, okay, our equilibriant is our equal and opposite direction force. So our force equilibriant is going to be down this way. Whoops, it's still black. It's down this way. Okay, so the force line is the same. The direction is just 180 degrees from it. So rather than solving for this force net angle, so maybe I can put in there, that is theta of, go back to black to label it, theta of, oh my goodness, this line tool, theta of F net. But what I want in this solution is I want, back to red, this angle. Right, I'm going to put this, I'm going to give it the whole width here. This theta value is just 180 degrees from that theta value. So I'm going to say this is theta of equilibriant. Okay, well, if we solve for that angle, we're going to get our angle of our equilibriant, and we can just use the same magnitude, but we're going to use this opposite sided angle. Okay, let's do that. So if we're solving for that, we're going to say theta, maybe I should put this in an equilibriant section. Say equilibriant. Equilibriant, a little bit messy, but it's okay. Theta is equal to the inverse tan of, what's opposite going to be, 30 newtons over 80 newtons. So that is equal to, when I solved it, that's going to be 69 degrees, and so this angle is going to be smaller. That's going to be the complementary one, so it's going to be 21 degrees, I believe. 21 degrees, and that is west of south. So our equilibriant value is 85 newtons at 21 degrees west of south. Alright, so here's our south direction going straight down. This is going west of south. I'm sure you guys have this strategy by now. Okay. If you're uncomfortable with this method, go check out example 2-2. And when we draw this triangle, you can use the same strategy of drawing that plane and flipping the angle if you like. Both are totally valid. I just thought it would be good to demonstrate each one once. That's all for lesson 2.